In this lecture, we will replace the player character controlled by you with a hero character from the Epic Marketplace and leave the rest of the characters as gods. Open the shooter gym level and run the game. You can see all the characters in the game as gods. Go to the folder Content Characters Cosmetics. Open the Pick Random Character Blueprint. Remove the Random Bool node. Add a Get Owner node which returns the controller. This controller can be either a player controller or an AI controller for bots. So cast to controller. And add a is player controller node. It returns true if player controller. Connect the output to the select node. In case of false, for the bots, select the B underscore guard. For true, select B underscore queen. Connect the output to new path class in the add character path node. Compile and save. Go back to the shooter gym level. Run the game. You can see the player controlled character as queen and the bots as god characters. Now let us add an interesting Epic Marketplace asset for the hero character. Go to the Epic Launcher. In the Marketplace tab, search for character. Select the free tag under max price. You can see an adventure character. Open it. First download it and then you will see the add to project button enabled. Click add to project. Choose the Lyra course project. Once added, go back to the Lyra project. You can see the folder man under the main content folder. Open the folder. In the subfolder mesh full, you can see 4 different skeletal meshes with t-shirt and jacket. You can try with different meshes. Now go back to the content characters cosmetics folder. Duplicate B underscore Manny. Rename it to B underscore hero. Open it. Select the mesh component. Under the skeletal mesh asset, select sk underscore man underscore full underscore 04. Open the skeletal mesh asset. Open the skeleton from the top right corner icon. Go to Windows, Asset Details. Under compatible skeletons, select sk underscore mannequin underscore skeleton. Save all. Back to the hero blueprint. Select mesh component and under animation anim class, select the animation blueprint as ABP UE4 mannequin retarget. This animation blueprint is used to retarget the UE4 skeletons. Compile and save. Go back to the pick random character blueprint. In the select node, instead of queen, now you can select B underscore hero. Compile and save. When you run the level, you can see the hero character as the player character and the opponents as guards. Thank you for watching this lecture. See you in the next one. In this lecture, we will create a MetaHuman character using Unreal Engine 5.2. Open metahuman.unrealengine.com in the web browser. I have used Chrome in this lecture. Launch MetaHuman Creator. Once the MetaHuman Creator is launched, MetaHumans you already created will be displayed. I have created a custom MetaHuman character for this course named MetaHuman A. You will be seeing this character during the course. Let us create a new MetaHuman. Select the Create tab. Choose one of the MetaHuman as the base character. Select Create Selected. From the tab below, you can check different pre-built animations to test your MetaHuman. Go to Blend and you will get an option to blend 3 more MetaHumans together. Once you select all the 3 MetaHumans, you will get the control points in the face. Just move them to adjust the face between the selected MetaHumans. You can also choose the skin, eyes, teeth, hair, and several other features for the MetaHuman. You can go to the top, bottoms, and shoes to design the costumes for the MetaHuman. Once you are done with the creation, test the animations with the MetaHuman. At the top left corner, you can enter the name for the MetaHuman and it will be saved. I have named it MetaHuman B. Thank you for watching this lecture. See you in the next one. In this lecture, we will replace the hero character with a meta-human character. Meta-human is Epic Games' realistic-looking human character. We will use a meta-human character created using the meta-human creator in this lecture. When you run the shooter gym level, you can see the hero character currently for the player character. We will replace this with the meta-human character. In the content browser, click Add. This opens the Quixel bridge. Go to the MetaHumans section. Under MetaHumans, you can see the MetaHumans already created by you using the MetaHuman creator with the same account logged in. Select the MetaHuman and download the MetaHuman in medium quality. Once downloaded, the MetaHuman will be listed in the local section. Select the MetaHuman from the local section, My MetaHumans, and click Add. Make sure you select the medium quality for this course. This is very important as the high quality metahumans are very resource intensive, which can slow down the game. Enable the missing plugins which are needed for the metahuman usage. Restart the Unreal Engine editor. Keep the shooter gym level open. You can see the metahuman files under the folder Content Metahumans. Go to the folder Content Metahuman A. I have named the metahuman as Metahuman A. You can find your metahuman accordingly. Open the metahuman blueprint BP underscore metahuman A. Under the live retarget section, select the retarget original anim class as ABP underscore mannequin underscore copy underscore pose. Compile and save. Go to the pick random character blueprint. Instead of B underscore hero, select the BP underscore metahuman A blueprint. Compile and save. Run the blueprint and you can see the metahuman in action. Thank you for watching this lecture. See you in the next one. In this section, we will understand Lyra player start and learn how we can use the player starts to spawn the player and the enemies in the locations we want. In the shooter gym level, we have 6 player starts. By default in Lyra, players and enemies are randomly spawned in the available player starts as much away from the opponent team members. We will learn to customize Lyra by writing a new logic for this player and enemy spawn behavior. Before we start this exercise, let us move the weapon spawners in the level to a corner to avoid disturbances. Let us select two player starts and move them to two different corners. The hero player and the enemy will be spawned from these corners. For one of the player start, give the player start tag name as hero and the other as shooter. Now let us make the changes needed to spawn the hero character at the player start tagged as hero and the enemy character at the player start tagged as shooter. Go to shooter core content, search for spawning rules. You can see the blueprint, team spawning rules. Open this blueprint. It is a blueprint derived from the C++ class TDM player spawning management component. Open the C++ class. The class is derived from the parent class Lyra player spawning manager component. Click Go to definition and open the parent class Lyra player spawning manager component header file. The function onChoosePlayerStart is responsible to find the best player start for the spawned character. We will expose this method to the blueprint and implement the new logic in the blueprint. This method passes in an array of player starts and the controller and returns the best player start for the player to spawn. Add a const in front of the T array of Lyra player starts. This is needed for the player starts to be available in the blueprint as input. Go back to the child class TDM player spawning management component header file. Add the const in front of the T array of Lyra player starts. Remove the virtual in front. Add the attribute uFunction blueprint implementable event and a meta tag display name as onChoosePlayerStart. This name appears in the blueprint. Click on the onChoosePlayerStart function and go to definition. We can see the actual implementation in the CPP file. Comment out this full implementation. We will have a new logic implemented in the blueprint. Next, search for Lyra PlayerStart class. Open the Lyra PlayerStart header file. Add a uFunction blueprint callable attribute to the function isClaimed. This method will be used in the blueprint logic to check if the player start is already used. Build the project. Please ensure the Unreal project is closed when you compile the project in Visual Studio. Once the build is successful, close the Visual Studio and open the Unreal project. Open the Team Spawning Rules blueprint. Open Full Blueprint Editor. You can see the event graph now. Under Overrideable Functions, select onChoose Player Start. You can see that the player start array and the controller are exposed in the input. And the return value is the Lyra player start. The logic we will implement is as follows. Whenever the hero player is spawned, this blueprint will execute and loop through all the available player starts placed in the level. During the loop, if a player start is identified with the tag hero, the first Lyra player start with the tag hero will be returned. Before that, a check will be made to see if the Lyra player start is already claimed. Otherwise, it will be returned by the onChoose player start function. The same applies to the shooter enemy if the player start has the shooter tag on it. Let us create two helper functions first to keep our blueprint simple. Create a new function isValidPlayerStart. Add two input parameters, a tag of type string and a player start of type object reference of Lyra player start. From the input parameter player start object, get its variable player start tag. Check if the player start tag is equal to the input parameter tag. Additionally, check if the player start is not claimed. Use a boolean not to check not claimed and use boolean and to ensure if both conditions are true. The function returns true, otherwise false. Pass the return value to the return node. Add a isValid boolean return parameter. Create a new function getValidPlayerStart. Add two input parameters, a Lyra player start array of type Lyra player start object reference and a player start tag of type string. Use a for each loop with break to loop through the player starts. Use the helper function isValidPlayerStart created early to check if the player start in the current loop is valid. Make the helper function a pure function. Pass in the player start in the current loop and also the tag passed as input to the function. Use a branch node and check if the isValidPlayerStart function returns true. Then break the for each loop. The completed flow returns the valid Lyra player start. Add a Lyra player start to the return node. Open the onChoosePlayerStart. We will have the main logic here calling the helper functions. Use a isAnode to check if the passed in controller is of type B underscore AI controller underscore Lyra shooter. Use a branch node to check if true. Then use the getValidPlayerStart function with the player start tag as shooter. Pass in the Lyra player start array. If false, then use the getValidPlayerStart function with the player start tag as hero. Pass in the Lyra player start array. In both cases, return the valid Lyra player start. Now go to the shooter gym level. Notice the two player starts with tags hero and shooter. Start the game and you can see the hero and the shooter enemy spawned in their respective player stats. You can also go to the editor preferences, Lyra developer settings and disable the allow player bots to attack for troubleshooting. Thank you for watching this lecture. See you in the next one. In this section, we will learn how the shooter bots are created in Lyra with artificial intelligence. We will explore the different Unreal Engine AI concepts applied for the shooter bot. In an upcoming section, we will design a new melee-based bot from scratch. Go to Plugins, Shooter Core Content, Bot folder. Open the Shooter Bot spanner. This Lyra bot creation component is responsible for creating the bots in Lyra. We can have multiple copies of this component for different types of bots. There are two important fields to be noted in this component. Bot controller class is the AI controller configured for the specific type of bot. We will have separate AI controllers created for each type of AI bot. Number of bots to create controls the number of bots of this specific type of AI. In the same folder, open the B AI controller Lyra shooter. The AI controller is already pre-configured with the required fields. It is derived from Lyra player bot controller. In the details section, go to the default section. The enemy name key is the blackboard key for the target enemy. We will go through the blackboard shortly. BT asset is the behavior tree configured for the AI bot. Open the behavior tree BT Lyra shooter bot. Behavior tree is the brain for the bot. In this course, we will not cover the entire Unreal Engine AI features. We will explore the behavior tree developed for the shooter bot, and in a later section, we will create a new behavior tree for the melee AI bot. Behavior tree is a top-down tree structure which is executed from left to right at all the levels. First, let us understand a few concepts we will use in the behavior tree. Once we understand the basics, we will cover the complete behavior tree for the shooter bot. Selector is a parent node with multiple child nodes. The child nodes execute from left to right. If any of the child nodes succeeds in the order, the other nodes will be ignored. But if any of the child nodes fails in the order, the next child node will be executed. Sequence is a parent node with multiple child nodes. The child nodes execute from left to right. If any of the child nodes succeeds in the order, the next node will be executed. But if any of the child nodes fails in the order, the other nodes will be ignored and the sequence parent node is failed. In this example, the root node has a selector child node, selector A. Being a single node without any condition, it always gets executed. This node has three child nodes, selector B, sequence A and selector C, each with a condition. They will be executed from left to right. Selector B condition is false, so sequence A gets executed, which executes the step C and step D. If step C and step D succeeds, selector C will not be executed. This behavior tree execution is a cyclic process and it keeps repeating. The condition keeps getting changed dynamically at runtime. And based on this change in the condition, the selector node execution also gets changed. Now, if the selector B condition is true, the sequence B gets executed where the step A and step B gets executed in order. In case something fails in the sequence, selector B gets failed and then sequence A gets executed and so on. With this basic knowledge about the selectors and the sequence, let us get into the actual behavior tree for the shooter board. Go to the plugins, shooter core content, board, BT folder. Open the BT Lyra ShooterBot behavior tree. This behavior tree is the brain for the shooter bots. Before getting into the details, note that this same functionality for the behavior tree can be achieved by several ways. We will follow the behavior tree example from ShooterBot. The behavior tree starts with a root node. Nodes below the root node can either be a selector or sequence. The root node has one selector node. The selector node has two child nodes. The left node drives the logic for scenario when the shooter has ammo. The right node drives the logic when the shooter has no ammo. Let us go through the left node first. The left node itself is another selector node. This node will be executed when a blackboard condition is true. A blackboard is a set of variables associated with the behavior tree. The variables are called blackboard keys. You can open the blackboard for this behavior tree from the top right corner. You can see 4 keys there. Self factor is an inbuilt variable denoting the bot itself. Target enemy is the variable set to denote the enemy at whom the bot will fire the bullets. Target enemy is of type Lyra character. Move goal is the next location for the bot to move. The AI will keep finding an optimal route for the bot to move around targeting the enemy. Out of ammo is the boolean variable which holds the value true or false based on the availability of the ammo for the bot. Now back to the child node. The first thing, we will explore the have ammo decorator. A decorator is attached to the selector node. It is a boolean condition which decides whether to execute the selector or not. This is a blackboard condition based decorator. If the blackboard variable out of ammo is false, this node and below gets executed. Otherwise, this selector node is skipped and the next node to the right gets executed. Let's consider the case blackboard variable out of ammo is false. So in this case, the selector node gets executed. Lyra uses EQS or the environment query system to get data about the surrounding environment in this behavior tree. We won't get into the details about EQS for now. We will use the readily available helper methods provided in Lyra for the EQS queries. We will understand how EQS is used in Lyra as we explore this behavior tree example. The first run EQS query is the AI perception used to detect enemy. This query will check if there are any enemies around using AI site perception. If an enemy is found, the EQS will set the blackboard key target enemy. This query is executed every half a second to check if any enemy is in sight. The selector node has 3 child nodes. The first node is a sequence node, shoot and move. It has a blackboard based condition for the key target enemy. If target enemy is set, the enemy is visible and this node gets executed. The node also has a custom blackboard condition BT decorator allowed to fire. This is for troubleshooting the behavior tree. If you go to Edit, Editor Preferences, Lyra Developer Settings, Under Lyra bots, there is a setting for allow player bots to attack. You can toggle this to true or false, and this is purely for development testing. There are two behavior tree services in this node, shoot and set focus. The shoot service triggers the gameplay ability weapon fire. Initially, the bot will have a pistol by default with additional ammo. If the ammo is completely over after repeated firing, the shoot service sets the out of ammo value to true. The set focus service lets the bot change its direction and focus towards the target enemy based on the blackboard key target enemy. This way, the bot shoots at the target enemy. This sequence node has two child nodes. The first node is the run EQS query, find best position. This EQS query keeps finding a best position to shoot against the enemy. The run EQS query sets the blackboard key move goal. The second node in the sequence is move2. This node moves the bot to the location set in the blackboard key move goal. Till now, we explored the child node for the scenario when an enemy is found. The second child node is a selector node looking for task. It has a blackboard based condition for the key target enemy. The node gets executed if the target enemy value is false. It means enemy is not visible. There are two services. Clear focus removes the focus on the target enemy, and the reload weapon service triggers the gameplay ability reload weapon to the weapon held by the shooter bot. This selector node has a child selector node, which again has two other child sequence nodes. Search new weapon node has a EQS query to find a weapon and get a location for the weapon. The move goal blackboard key is set here. Move to node moves the shooter bot to the move goal location where the weapon is found. The same logic is applied in the next node, search for player. In this case, the search for enemy node is an EQS query which finds an enemy location. This is different from the AI perception EQS query we used earlier. In this case, search for enemy node queries the environment for any Lyra characters which are in the opponent team and finds the location. The move to node moves the shooter bot towards the enemy location. The third child node is the wait node, which will get executed if the other nodes in the left of the selector fails. Now, let us see the second child of the top selector node, which is again a selector node. It has two child nodes again. The first node is a sequence node. This node executes when the out of ammo blackboard key is set. The clear focus service is called to remove the focus from the enemy. BTS check ammo service is called to check the ammo status of the weapon, and out of ammo blackboard key is set accordingly. The sequence node has two child nodes, run EQS query for search for weapon and move to node to move towards the weapon spanners. The wait node will get executed if the other node in the left of the selector fails. Thank you for watching this lecture. See you in the next one. In this section, we will implement the unarmed spawn functionality to the characters in the game. By default in Lyra, the characters are spawned with a pistol and the animation layer is set to pistol animations. When the weapons are acquired and swapped, the corresponding locomotion animations are changed. We will remove the default weapon and also initialize the hero mannequin with the unarmed animations in this section. Go to Shooter Core, Content, Game, and open the blueprint for Hero Shooter Mannequin. Go to the variables section. Remove pistol from the weapon ID. Remove the initial inventory items. Now we will set up the unarmed animation layer for the character. Open the add initial inventory function. Add a boolean variable unarmed. If the inventory has items, set unarmed to false, else set unarmed to true. Next, let's set a timer which calls a function to initialize the unarmed animations after the actor got initialized. Create a function initAnims. Go back to the event graph. In the hide actor until its initialized section, add the set timer by function name node after the set actor hidden in game node. This calls the timer after the actor gets initialized before spawn. In the function name, add initAnims. Set a very minimal time value 0.05 and looping true. From the return value, promote to a variable initAnim handle for the timer handle. This handle will be used inside the initAnims function to kill the timer after it gets executed once. Open the initAnims function. If the unarmed value is true, call the link anim class layers node and set the animation layer to ABP unarmed. After that, call the clear and invalidate timer by handle using the timer handle variable. If the unarmed value is false, directly invalidate the timer handle. Save it and open the shooter gym level. You can see a glitch here where an initialize animation is loaded first holding a pistol. This is loaded from the gameplay ability spawn effect. Search for GA_spawn effect from the shooter core content. Open the GA_spawn effect. You can see the play montage section with the spawn animation. You can either use a different animation here or you can remove this montage. We will remove this montage and directly connect to the end ability node. This should fix the spawn animation. Thank you for watching this lecture. See you in the next one. In this section, we will create a behavior tree or the brain for a melee bot. The melee bot will have the following abilities. The ability to sense the enemy in the surroundings and move towards the enemy. The sight perception to see the enemy and change its behavior accordingly. We will have 4 behaviors. Nothing, the default behavior when the bot starts. Attack, the behavior changes to attack based on the distance between the bot and its enemy, when the target distance is less than or equal to the max attacking range. The attack behavior has 3 attacking ranges: far range, medium range, and a close range. It depends on the distance between the bot and the enemy. When the target distance is less than or equal to the close attacking range, attack range is close. The bot attacks the enemy. When the target distance is less than or equal to the medium attacking range, the attacking range is medium. The bot keeps moving to the enemy. When the target distance is less than or equal to the max attacking range, attack range is max. The bot makes a heavy jump and move towards the enemy. Else the behavior is set to chase. Chase. During chase, the bot speeds up and follows the enemy on sight. Patrol. If the enemy is not seen, behavior is set to patrol. During patrol, the bot uses the EQS system to search for the enemy and moves closer to the enemy so that the enemy can be seen via sight perception. And that's the overall design of the behavior tree for the melee bot. Let us create 2 enumerations for the AI behavior and AI attack range. Go to the shooter core content, bot, BT folder. Create a folder enumerations. Create an enumeration under blueprints. Name it EAI behavior. Enumerations are used to provide textual representations for the list of AI behavior and AI attacking range values. Add the enumerators for nothing, patrol, chase, and attack. Create an enumeration EAI attack range. Add the enumerators for far, medium, and close. Now let's create the empty behavior tree and the blackboard for the same. Go to the shooter core content, bot, BT folder. Right click and create the behavior tree under the artificial intelligence menu. Name it BT Lyra Melee Bot. Open the behavior tree and there will be a single root node. We will not design the behavior tree for now. Instead, create the blackboard for the behavior tree and the needed behavior tree services. Click the new blackboard. Name it BB Lyra Melee Bot. Now the blackboard will be enabled for the behavior tree in the top right corner. Click on the blackboard. We will now add the blackboard keys needed for the behavior tree. Click the new key. Add the key target enemy of type object, Select the base class as Lyra character. Add the key move goal of type vector. Add the key out of ammo of type boolean. Add the key AI behavior of type enum and enum type AI behavior. Add the key AI attack range of type enum and enum type AI attack range. Let us create the update behavior tree service. This service will be later used in the Mellibot behavior tree. On the top of the Mellibot behavior tree, select BT service blueprint base from the new service dropdown. Name the service as BTS update behavior. Let us add a few variables to be used in this behavior tree service. Add a variable Mellibot of type Lyra character. Add a variable Mellibot controller of type AI controller. Add a variable target key of type blackboard key. Add a variable behavior key of type blackboard key. Add a variable attacking range key of type blackboard key. Add a variable enemy found of type boolean. Add a variable for attacking range of type float. Add a variable medium attacking range of type float. Add a variable close attacking range of type float. Under functions, create a new function setBehavior. This function is used to set the behavior key in the blackboard from the behavior tree service. Add an input named behavior of type EAI behavior. Add a set blackboard value as enum node. Connect the behavior input to the value. Use the behavior key variable and connect to the key. The value for the behavior key will be set from the behavior tree later. Create a new function setAttackingRange. This function is used to set the attack range key in the blackboard from the behavior tree service. Add an input named attack range of type EAI attack range. Add a set blackboard value as enum node. Connect the attack range input to the value. Use the attack range key variable and connect to the key. The value for the attack range key will be set from the behavior tree later. Create a new function update behavior. Add the melee bot controller and melee bot variables and check for validity. If both are valid, then set the local variable target actor from the blackboard value for target key. This value will be set from the behavior tree by AI perception. Check if the target actor is valid. If valid, set enemy found true or else set false. If enemy not found, call set behavior function and set to patrol. If enemy is found, calculate the distance to target. Use the get distance to function to get the distance between the target actor, which is the enemy, and the bot. Set the distance to target variable. check if distance to target is less than or equal to far attacking range. If true, set behavior to attack. If false, set behavior to chase. In the positive flow, check if distance to target is less than or equal to close attacking range. If true, set attacking range to close. Else, check if the distance to target is less than or equal to medium attacking range. If true, set attacking range to medium. Else, check if the distance to target is less than or equal to far attacking range. If true, set attacking range to far. If false, set behavior to chase. We have completed the update behavior BT service. Now let us create the main events in the event graph. Search for event receive search start AI and add it. This is an inbuilt event which provides the owner controller and the controlled pawn. Set the variable MeleeBot controller with owner controller. And cast the controlled pawn to Lyra character and set MeleeBot variable. Search for event receive activation and add it. This event is executed when the bot is started. Call set behavior function here and set behavior to patrol. Search for event receive tick AI and add it. This event is called repeatedly. Call the update behavior function here. Now let us create the BT task set movement speed. Select BT task blueprint base from the menu new task in the behavior tree. Name it BT task set movement speed. Add a variable movement speed of type float. Set visible to make it public and the value will be set from the behavior tree later. Search for event receive execute AI and add it. Using the controlled pawn, get the character movement component using the get component by class. Set the max walk speed of the character movement component using the movement speed variable. Use the finish execute node to complete the task. Set success to true. Now let us create the BT task jump. Select BT task blueprint base from the menu new task in the behavior tree. Name it BT task jump. Search for event receive execute AI and add it. Cast the controlled pawn to character. Call the jump function in the character. Finish the task using the finish execute node. Set success to true. Now let us create the BT task perform attack. Select BT task blueprint base from the menu new task in the behavior tree. Name it BT task perform attack. Search for event receive execute AI and add it. Add the node send gameplay event to actor. Add the controlled pawn to the actor. Add the event tag input tag .ability.melee which will activate the melee ability for the bot. Finish the task using the Finish Execute node. Set success to true. Now let us create the BT task perform attack. Select BT task underscore blueprint base from the menu new task in the behavior tree. Name it BT task underscore perform attack. Search for event receive execute AI and add it. Add the node send gameplay event to actor. Add the controlled pawn to the actor. Create a new event tag under input tag ability and name it melee chimera. You can now see the tag as input tag.ability.melee chimera. This will activate the melee ability for the bot. Finish the task using the finish execute node. Set success to true. Thank you for watching this lecture. See you in the next one. In this lecture, we will get a monster character for the melee bot. Let us get a free paragon character, Chimera, for the melee bot. Open the Epic Games launcher. Search for Chimera in the marketplace. The monster character has various skins. You can later choose the skin you wish. Add it to the Lyra course project. At the time of recording, the asset supports still Unreal Engine 5.1 version. Click Show All Projects. Select the course project. Select version 5.1 and add to the project. In most cases, it should be fine to download a nearest previous version asset and it will work right. You can see the folder Paragon Chimera under Content folder. Open the Characters Cosmetics folder. Duplicate B underscore Manny. Rename it to B underscore Chimera. Open the blueprint. Select the mesh component. Under Skeletal Mesh, choose Chimera Bengal. It is one of the skins for Chimera. Open the skeletal mesh. Click on the skeleton icon to open the skeleton for Chimera. Go to Windows Asset Details. Under Compatible Skeletons, add SK_mannequin skeleton. This is the UE4 skeleton compatible in Lyra, and also Chimera uses a UE4 skeleton. Save all. In the Chimera blueprint created earlier, in the details section, choose ABP_UE4_mannequin_retarget as the animation blueprint for the anim class. Compile and save. Open the Pick Random Character blueprint under Characters Cosmetics. Change the guard blueprint to Chimera blueprint. Compile and save. Go to the shooter gym level. Open Editor Preferences and Lyra Developer Settings. Uncheck the Allow Player Bots to Attack. Run the level. You can see Chimera in the ideal position. Next, we will create the animation montage for the melee action by Chimera. For this, we will retarget a melee animation available with the Chimera asset and use it in Lyra. Go to the Animations folder inside Chimera asset. Open the animation melee_a. We will use this animation in Lyra. Right-click melee_a and select Retarget Animation Assets, Duplicate and Retarget Animation Assets. Select the IK retargeter as RTG_UE4 Mani_UE5 Mani. Select the source skeletal mesh as Chimera Bengal. Target skeletal mesh as SKM Mani. Click Change to select the target folder as Content Mannequin Animations. Click Retarget. This will create a new animation which will work in Lyra compatible to the UE5 mannequin. Now create a new folder in the Animations folder. Name it Chimera Animes. Move the retargeted animation to this folder. We will now create an additive animation for this retargeted melee animation. This additive animation is needed to create an animation montage for melee. Duplicate the animation. Rename it to melee_a_additive. Open it. In the Asset Details section, go to Additive Settings. Select the additive anim type as local space. Base pose type as frame from this animation. Save the additive animation. Go to the Content, Characters, Heroes, Mannequin, Animations, Actions folder. The Action folder has all the animation montages used in Lyra. Search for melee. Open the AM_MM_pistol_melee animation montage. You can see a pistol melee animation which is hitting with a pistol and an additive animation for the same in this animation montage. We will reuse this animation montage for the Chimera melee animation montage. Duplicate AM_MM_pistol_melee and rename it to am underscore mm underscore chimera underscore melee. Move this newly created animation montage to the chimera animes folder. Open the am underscore mm underscore chimera underscore melee animation montage. Select the animation mm underscore pistol underscore melee and replace it with melee underscore a in the chimera animes folder. Replace the mm underscore pistol underscore melee underscore additive animation with the melee underscore a underscore additive animation in the chimera animes folder. Save and close. Thank you for watching this lecture. See you in the next one. Lyra has an inbuilt melee gameplay ability which is used with the guns. When the character holds a gun, by pressing the E key, the melee gameplay ability is triggered and the character uses the gun to hit the enemy. We will use this gameplay ability to implement the melee behavior to our bot. In this melee ability for the bot, we won't use any specific weapon. The Paragon asset Chimera has the weapon already attached to the body. So we will use the unarmed animation layer in Lyra and use the melee ability without attaching any weapon. In a future section, we will implement the melee ability for the character with actual sword and a shield. For now, let us follow with a simpler approach to start with. Go to the root folder, search for GA underscore melee. Use the show in folder view to go to the specific folder. Duplicate the gameplay ability and rename it to GA underscore melee underscore chimera. Open it. We won't use a specific weapon, so remove the section Get Active Weapon Type. Also, remove the cast to weapon instance base and the melee attack montage attached to it. Instead, we will use the montage variable available in the gameplay ability. Attach the variable to the montage to play. Reconnect the commit ability node to the play montage and wait node. Select the montage variable and set the animation montage am underscore mm underscore chimera underscore melee. Compile and save. Go to the class defaults and details section. Under triggers, add a new trigger. Add the tag input tag.ability.melee chimera which we created earlier. This is a gameplay event tag which will be triggered from the behavior tree task. Next, we will create a cooldown gameplay effect for the melee bot. Cooldown is basically to avoid repeated melee activity within a specific time period. Search for cooldown and select G underscore hero dash underscore cooldown and go to the specific folder using show in folder view. Duplicate GE underscore hero dash underscore cooldown Rename it to GE underscore chimera underscore melee underscore cooldown. Open the gameplay effect. Go to gameplay effect section, duration magnitude. The scalable float magnitude value denotes the wait time between the melee action. In the gameplay ability GA melee chimera, under the cooldown section, add the newly created GE underscore chimera underscore melee underscore cooldown. Compile and save. Thank you for watching this lecture. See you in the next one. In this lecture, we will continue with our melee bot behavior tree creation. Go to the shooter core content bot BT folder. Open the behavior tree BT Lyra melee bot. Choose the blackboard asset for the behavior tree BB Lyra melee bot. From the root, drag a new node. Choose selector. We will add two services for this main selector. Right click, add service, run AQS. Select it and go to the details section. Choose the query template as EQS AI perception enemy. This is an inbuilt EQS query in Lyra. It will query the environment and get a Lyra character if visible to the bot. When the Lyra character is visible, it will set the target enemy blackboard key to the Lyra character. Set the node name as AI perception used to detect enemy. Leave the other field to their default. Right-click the selector and add service BTS update behavior. Select it and in the details section, set the variables we declared earlier during the service creation. Far attacking range to 800, medium attacking range to 450, close attacking range to 300. Choose the target key blackboard key to target enemy. Just to remind, the target enemy is set by the AI perception EQS query service. Choose the behavior key blackboard key to AI behavior. Choose the attacking range key blackboard key to AI attacking range. The service interval value is set by default to 0.5. So this service executes every half a second. Drag from the selector and create a sequence. Right click and add a decorator blackboard. Rename the node name to nothing. Select the blackboard key AI behavior and the key value nothing. Select observer aborts to self. This means when the blackboard key AI behavior is set to nothing, this sequence will be executed. Same way, add another sequence and the blackboard condition named attack. Choose blackboard key as AI behavior and key value as attack. Select Observer Aborts to Self. This sequence executes when the AI behavior is set to attack. Repeat the same steps for chase, when the AI behavior is set to chase, and AI behavior set to patrol. Drag from nothing sequence and add a wait node. If AI behavior is nothing, the bot waits for 5 seconds until the AI behavior changes. Drag from the attack sequence and add another selector. From the selector, drag and add a sequence. Add a blackboard based condition. Name it for range. Select the blackboard key as AI attack range. Key value as for observer aborts to self. Follow the same approach to add 2 more sequences for AI attack range, medium range, and close range. Now for the far range, drag and add a BT task jump. Add another task in the sequence move to and set the move to value to blackboard key target enemy. For the medium range, we don't do much but move the bot to the enemy. So add the move to task and set the blackboard key to target enemy. For the close range, call the BT task perform attack. From the chase sequence, drag and add BT task set movement speed. Set the movement speed variable to 400. Add a move to task to the sequence and set the blackboard key to target enemy. For the patrol sequence, we will keep a very simple logic. The actual patrol sequence involves setting up the patrol path for the bot, but in our case, we will do an EQS query and search for the bot's enemy nearby and move closer to the enemy. Drag from patrol sequence and add a run EQS query task. Choose the query template and select EQS Find Target. Choose the blackboard key as Move Goal. Rename the node to Search for Enemy. Check the Ignore Restart Self Boolean flag to true for the Run EQS query. EQS Find Target is an inbuilt EQS query in Lyra to find a Lyra character in the environment nearby and set the blackboard key. Add another task Move To in the patrol sequence and set the blackboard key Move Goal. Thank you for watching this lecture. See you in the next one. In this section, we will configure the behavior tree for the Melee bot. Go to the shooter core content bot folder, duplicate the B_AI_controller_Lyra shooter, rename it to AI_controller_Lyra Melee. Open it. Change the BT asset to BT_Lyra_Melee_bot. Compile and save. Next, duplicate the shooter bot spawner and rename it to Melee bot spawner. Open the Melee bot spawner. Change the bot controller class to B_AI_controller_Lyra Melee. Now the Melee bot spawner is configured to spawn Melee bots. Currently, the number of bots to create is set to 1. Compile and save. Go to the Experiences folder and open the Shooter Game Elimination Experience. Change the Shooter Bot Spawner to Melee Bot Spawner. We need to make another change to add the Melee ability to the character. Open the default pawn data, hero data underscore shooter game. Open the ability set shooter hero. Add a new ability item to the list. Select the ability GA_Melee_Chimera. Add the input tag.ability.melee_chimera. Now the Melee bot is activated with the new Melee behavior tree. But the player loses 100% health in a single hit. Let us go and investigate the gameplay ability Melee Chimera. Open GA_Melee_Chimera. Go to the Apply Gameplay Effect to Target section in the blueprint. Navigate to the folder containing GE_damage_melee. This is the Melee gameplay effect. Duplicate the same. Rename it to GE_damage_melee_chimera. Go to the Executions, Calculation Modifiers, Modifier Magnitude, Scalable Float Magnitude. Change the value 100 to 10. Now for each hit, the damage will be 10. Compile and save. In the gameplay ability GA_melee_chimera, change the gameplay effect to GE_damage_melee_chimera in the Apply Gameplay Effect to Target node. Compile and save. Open the shooter gym level and run it again. We can see that the melee damage is 10 each time when hit. Thank you for watching this lecture. See you in the next one. In this video, we will start creating a new map or level in Lyra for the spruce forest biome. As a first step, we will create the landscape and the landscape material. The landscape material created in this foundation course will be a basic one, but highly extendable for a variety of needs. We will extend the same landscape material to add more features to it in the upcoming advanced courses. By the end of this video, we will create a landscape for the spruce forest with two areas in the forest. A mossy spruce forest floor, which is deep into the jungle with spruce trees and a lot of shrubs and densely populated plants. Then a path area which is scarcely populated with dry plants without trees. Basically an area for the player to fight with the enemies. In this video, we will create the landscape material first, which we will later apply to the landscape and bring it to life with the textures from Pixel Megascans. Open the Lyra project, browse to the plugins and Shooter Maps content folder. Create a new folder, Landscape Material. Right-click in the content browser and under Materials section, create a new material. Name it M_landscape. Open the landscape material. Select the visible landscape output node and choose Use Material Attributes. The node gets collapsed. Add the material attribute layers and connect to the landscape output node. Create a Set Material Attributes node. Connect it to the Material Attribute Layers node. In the Set Material Attributes node, add only the Customized UV1 attribute. Customized UV1 attribute has two channels, U and V, where we will add the two landscape layers, forest floor and the path. Create the landscape layer samples for the two layers, forest floor and the path. We will call the forest floor as ground layer and the path as path layer. Create a Make Float 2 node and connect the landscape layer samples, ground and path to it. The Make Float 2 node will take the two layers and make a two-dimensional vector. Connect it to the customized UV1 attribute. Save the landscape material. Now right-click on the landscape material folder and under materials section, create a material layer ML_main. This is the main material layer where we can add any number of material layers to our landscape. This is more like a template to add the actual textures in the future steps. Open the ML_main material layer. Select Set Material Attributes nodes. Add the base color, ambient occlusion, roughness and normal map attributes. Add a texture sample with parameter 2 node for the base color. Change the sampler source to shared ramp. Leave the default texture with sampler type as color. Duplicate the base color texture sample node 2 times. Name them as ORD and normal. The default normal map texture is not present, so we need to enable the engine settings. In the content drawer, under the settings section, enable show engine content. Now the default normal texture will be available. In the texture sample node for normal map, change the sampler type to normal. These are just the placeholder texture for this template material layer. Connect the RGB of the base color to the base color of the set material attributes node. Connect the R of the ORD node to the ambient occlusion. Connect G of the ORD node to the roughness. Connect RGB of the normal node to the normal of the set material attributes. Add an absolute world position node. It will be listed as world position in the right-click menu. Connect it to the component mask node. Select only the R and G for the mask. Add the mask output to the multiply node. Also add a single float value to the multiply. To add this, click the 1 key and at the same time, left click on the canvas. Now right click on the node and convert to parameter. Name it detail mapping scale. This value is to fine tune the texture scaling for the landscape for each landscape layer separately. Keep a default value of 0.001. We will look into this in action very soon. Connect the multiply output of the UVs of all the 3 texture sample nodes to have a uniform scaling of the textures. Save it and close the material layer. Now create another new material layer, same like before. Name it as ml_none. Don't make any changes to this material layer. Leave it at its default. This will be used as a background layer. Right-click on the landscape material folder and create a material layer blend under materials section. Name it MLB_ground. This is the blend layer for the forest floor or the ground layer. The blend layers are used to determine where in the landscape the specific landscape layer will be painted. This is an important feature in the landscape material creation. In this course, we are just starting with the landscape material with 2 simple layers. But in later courses, we will expand this landscape material to create different biomes with mountain slopes, snow, and so on. Open the MLB_ground, right-click, and add a Get Material Attributes node and add a customized UV1 attribute to it. Using this, we will retrieve the landscape layer sample ground. Connect the input top layer to the Get Material Attributes. Use the breakout float2 components to split the data from customized UV1 attribute. Get the landscape layer sample ground from the R channel and connect it to the alpha attribute of the blend material attributes. Duplicate the MLB_ground and rename it to MLB_path. Open MLB underscore path, and the only change you need here is to reconnect the alpha with the G channel, which provides the landscape layer sample path. Before we download the textures from Quixel Megascans, we need to disable virtual texture support for the project. Virtual textures is a feature in Unreal Engine to gain performance improvement for texture rendering. It has its own advantages and disadvantages. For now, we will not use the virtual textures in this project. At a later stage during performance optimization, we will look into virtual textures. Go to Project Settings, search for Virtual Textures, and disable both settings, Enable Virtual Textures on Texture Import and Enable Virtual Texture Support. Now restart the project. Next, we will create the landscape material instance. Right-click the M underscore landscape and select Create Material Instance. Name it MI underscore landscape. Open the MI underscore landscape. Open the Layer Parameters tab. If this tab is not visible to you, open the same from Windows menu and select Layer Parameters. In the Layer Parameters, you will find two sections, the Background section and the Material Layers section. Clicking the plus sign for the material layers, you can add any number of landscape layers. Under Background, select the ML underscore none as the background layer. Add two layers to the material layers. Rename them to Ground and Path. In the layer asset, select ML underscore main for both the layers. Using blend asset, add MLB underscore ground for the ground layer and MLB underscore path for the path layer. Save the files. Next, we will add the textures for our landscape layers from the Quixel Megascans. You can refer to the previous video on how to browse through the contents in the Quixel Megascans for the 3D assets and textures and bring it to the local cache. We will use the locally downloaded textures from Quixel Megascans in this video. Add Quixel content, which opens the Quixel bridge. Under the local section, you can find all the already downloaded textures from Quixel Megascans. Browse through the textures you need and add them to the project. In our case, we will use the mossy spruce forest floor textures. We will use the medium quality textures, which is 2K. You can download higher resolution based on your needs. In a future video, we will also look into how we can reduce the texture size dynamically to improve performance. You will see the added textures under the Megascans Surfaces folder in the main content folder. Same way, add the forest floor textures to the project. Open the MI underscore landscape and in layer parameters, expand the layer asset, texture parameter values, select the base color, normal and ORD and drag and drop the corresponding textures added from Quixel Megascans. You can identify the textures suffixed with underscore D for base color, which is also called diffuse, underscore N for the normal and underscore ORD for the ORD texture. Do this step for both the ground and path layers. The detailed mapping scale under the scalar parameter values have the default value of 0.001. This can be changed to your needs later. Save all. Now using the file menu, create a new basic level. Remove the floor static mesh actor. Save the level as jungle map under the maps folder in the shooter maps content. Go to the landscape mode and with default values, select create. A new landscape will be created. We will not get into the details of the landscape sculpting using the inbuilt tools in this course, but we will look into advanced workflows on creating landscapes for different biomes in upcoming courses. In this course, we will use a simple landscape for our jungle biome. Just use the sculpt tool and with a low tool strength and a higher brush size, click on various parts of the landscape, sometimes using the shift button pressed. This will create an uneven landscape for our jungle. Save all. Go back to the selection mode. Select the landscape and under the landscape material, select the mi_landscape created earlier. You should see a dark gray color to the landscape now. Go back to the landscape mode. Under the paint tab, click the plus right to the paint layers. This creates the layer info for the paint layers. Save it in the maps folder or the landscape material folder. Repeat the same steps for both the ground and path layers. Now you can fill the landscape with a single layer by right-clicking on the paint layer and fill layer. You can also paint the path layer on top of the ground layer by selecting the path layer. You can go back to the selection mode and select landscape and then mi_landscape. Under layer parameters, the detailed mapping scale value can be changed to scale down or scale up the landscape textures. This landscape will be covered by trees and plants, so the tiling of the textures will not be visible. But in later courses, this landscape material will be extended to bring in advanced features specific to the biomes. In the next section, we will add trees and plants to our landscape. Thank you for watching this lecture. See you in the next one. In this section, we will create the spruce forest biome on top of the landscape created earlier. First, let's separate the forest floor or ground and the path areas in the forest. In the last section, we already filled the landscape with the ground layer. Now let us add the paths. Using the mouse middle button, zoom out the landscape so it will be easier to paint on top of it like we paint on a paper. Now go to the landscape mode paint tab and select the path paint layer. Adjust the brush size according to your needs and set a higher tool strength. Now start painting the path on the landscape. Once the path is painted, go to the selection mode again and select the landscape. Open the mi_landscape layer parameters from the Windows menu. Adjust the detail mapping scale value to your needs. Next, we will add the spruce tree environment for the landscape. We will use the free medieval game environment asset from the Epic Marketplace, which has all the assets needed for this. You can always use your own assets or assets from the Quixel Megascans for this. Open the Epic Games launcher and search for the medieval game environment. At the recording of this course, there is no version 5.2 compatibility, so we can download the 5.0 version. I already have it downloaded in the machine, so it is available in the cache. In your case, you need to download it. First, we need to convert the project to Unreal Engine 5.2. For this, right-click the project and click Switch Unreal Engine version. Select 5.2 from the drop-down. Open the downloaded medieval game environment project. Once the project is loaded, go to the Content Environment Procedural Volumes folder. There will be 6 procedural foliage spawners. We will use 3 of them. The PFS forest to cover the forest ground area with spruce forest, trees, ground cover, ferns and rocks. PFS forest scatter to cover the overall area with scattered assets like broken tree branches, rocks and anything else you want to add. PFS shrub field for the grass cover over the path area. We will export the procedural foliage spawners along with the foliage assets to the Lyra course project. Select the PFS assets and right-click Asset Actions Migrate. If any pop-ups for saving the contents comes up, you can ignore and don't save. In the next pop-up window, you can see the assets to be migrated. Confirm by clicking on OK. Select the Lyra course project's content folder for migration. Now the contents will be migrated. Open the Lyra course project and go to the main content folder. There will be an environment procedural volumes folder with the three PFS assets. Open the PFS forest asset. Under the foliage types, you can find a list of foliage assets. There will be spruce trees full size, spruce trees half size, spruce plant bushes, ferns, ground cover plants, broken pine stumps, moss clusters, and more. A complete deep forest biome will be there. You can easily replace these assets with your own assets or assets from Pixel Megascans. The procedural foliage spanner has a list of foliage type objects which are of type foliage type instant static mesh. The plant static meshes are added to this foliage type instant static mesh objects. It's a good practice to prefix the static mesh assets with SM underscore and the foliage type assets with F underscore so that you can easily identify them. In the list of foliage types under the procedural foliage spawners, some of them might be gray colored. This is due to the virtual textures applied to them in the medieval game environment project. As we are not using virtual textures at the moment, these items can be safely removed. You can also remove few other foliage types if you focus more on performance. Depends on your needs of the game. You can keep the required foliage assets. Same applies to the other two procedural foliage spawners. PFS forest will be applied for the forest ground layer and the PFS shrub field will be applied for the forest path layer. PFS forest scatter will be applied throughout the forest in both the ground and the path layers. In order to achieve this, we will use the inclusion layer field in the foliage types files. For all the foliage types in the PFS forest, go to the advanced section under the placement section. Add an inclusion landscape layer and add ground. For all the foliage types in the PFS shrub field, go to the advanced section under the placement section. Add an inclusion landscape layer and add path. Now to place these foliages in the landscape, you will need procedural foliage volumes. You need to enable the procedural foliage experimental editor feature. Go to Edit, Editor Preferences. Search for procedural foliage and enable the same. Close the editor preferences. Now you can drag and drop the PFS forest into the viewport. Using the scale tool, scale the volume so that it is well spread across the entire landscape. Also make sure the height or the z-axis of the volume is high enough and there is a portion of the volume well below the landscape. You can place the procedural volume in the closer view of the landscape and then zoom out the landscape to scale it and position it easily using the scale and move tools. Follow the same steps for the PFS forest scatter and the PFS shrub field. Once it is done, click the Resimulate button from the Details panel for the PFS forest. The foliage types in the procedural foliage spawner will get spawned in the landscape now in the forest ground area. You can adjust the lighting for the scene by selecting the directional light and press right control button and L key. You will get a directional light widget in the viewport. Move the mouse cursor to get the time of the day light settings. Choose the right position for the sun to get the desired light settings that suits your game scenario. In the next video, we will check out an amazing marketplace asset called Ultra Dynamic Sky. This is a paid asset which costs around $40. Using this asset is completely optional for this course, but you will get great results for lighting the scene without any kind of efforts with ready-made lighting presets and weather conditions, and also with manual adjustments for lighting the scene. Again, using this asset is completely optional for this course as we deal with procedural and reusable assets to speed up the workflow, but still maintaining high quality results. Ultra Dynamic Sky is a very useful asset. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore an interesting paid asset to bring in a cinematic lighting and weather effect to our jungle scene in just a few clicks. This asset is completely optional and you can follow along with all other videos without applying this lighting and weather effects. But even if you are not going to use this, you can go through the lecture as a knowledge resource. Go to the Epic Marketplace and search for Ultra Dynamic Sky. If you buy this, Add to Project button will be enabled. Click Add to Project and choose the course project and Add to Project. Go back to the course project. You can see the Ultra Dynamic Sky folder under Content. To remove the current lighting and add Ultra Dynamic Sky settings, delete the directional light, exponential height fog, sky atmosphere, skylight, SM_sky sphere, and volumetric cloud. The scene will become completely dark. Now go to the Blueprints folder under Ultra Dynamic Sky. Drag and drop the Ultra Dynamic Sky blueprint into the viewport. You will immediately see the scene with proper lighting at the default settings itself. Now drag and drop the Ultra Dynamic Weather blueprint into the viewport. By default, it starts raining. Select Ultra Dynamic Weather and in the Details section, you will find a lot of presets for weather in the Weather property. Change it to different settings like foggy, partly cloudy, rain, thunderstorm, and you can experience the different weather for your scene. Thank you for watching this lecture. See you in the next one. In this lecture, we will configure our jungle environment with the shooter core experience and get the scene in action. Open Shooter Gym and run the level. You can see Chimera is in action as a melee bot. Let's change the settings. Go to Shooter Core Experiences. Shooter Game Elimination. Change the melee bot spawner to Shooter Bot Spawner. Compile and save. Open the Shooter Bot Spawner. Change the number of bots to create to 2. Go to Edit, Editor Preferences, Lyra Developer Settings. Allow player bots to attack to true. Select it. Go to Shooter Core Game Hero Shooter Mannequin. Under Variables, for Weapon ID, choose WID Pistol. For initial inventory items, add an item with ID Pistol. Go to Shooter Maps Content, Maps folder. Open the jungle map. Go to Window World Settings. Choose Shooter Game Elimination for the default gameplay experience. Also, choose Show FPS from the top left menu. This will display the frames per second metrics for the game in the top right corner of the viewport. Currently, we have placed our assets with high quality. We have a lot of optimizations which can be done to the texture size to get more FPS for our game. And also, we can use nanite settings for the static meshes. Run the level. You can see our metahuman in the jungle now. If your system can't handle the graphics, press Shift and F1 together. This allows you to use the mouse during gameplay. Go to the settings in the top right corner. Under Engine Scalability Settings, choose medium or low based on your system performance. Thank you for watching this lecture. See you in the next one. In this lecture, we will add the shooter bots to the level. Go to the add icon in the top left corner. Type Lyra player start and choose it. Drag and drop it into the level. You can click and drag the player start to the top, and while dragging, click end button in the keyboard to place the player capsule right on the ground. Now duplicate the player start by clicking on the Alt key and then moving the player start in the x-axis. You will now have two player starts. We will use this for the shooter bots. Close the world settings and open the details panel from the window menu. Select each of these player starts and enter shooter in the player start tag. Now add one more player tag away from these player tags. Enter hero in the player start tag. Now go to shooter core content blueprint. Drag and drop the B weapon spawner. Raise it and use the N key to place it right on the ground. In the details section, under Lyra properties, choose a color and select weapon pickup data underscore rifle for the weapon definition. Place two more weapon spawners near the shooter player starts. Select weapon definition for rifle and shotgun. Save all. Run the level. You can see two Chimera melee bots spawned in the same location as the player and they are not moving. There are three things to fix here. First, change the player spawn rules for the shooter bots. Second, change the Chimera character to guard. Third, set up a nav mesh for the shooter bots to move around based on their behavior tree. Go to the root folder, search for rules. The team spawning rules blueprint will be in the shooter content game folder. Open the team spawning rules blueprint. Change the player start tag from melee to shooter. Change the melee AI controller to B AI controller Lyra shooter. So now the logic will be to check the Lyra player starts with the tag named shooter and spawn the shooter bots there. Compile and save. Run the level. You can see the bots at the correct shooter tag Lyra player starts. Next, we will fix the shooter character. Go to the root folder, search for random and open the pick random character blueprint. Change Be Chimera to Be God. Run the jungle level. You can see the guards holding the weapon and hitting the character. But they still don't move. Let's create the nav mesh now. Click the add icon on the top left corner and search for nav mesh. Drag and drop the nav mesh bounce volume into the level. Using the scale option, increase the size of the nav mesh as much you want. And pressing P will show you the areas covered by the nav mesh where the AI bots can wander around. Press P again to remove the visibility of the nav mesh. Now run the level. And you can see the shooter bots in full action. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the push and up launch pads in Lyra, which are used for the player to jump to high levels and also do a quick push forward. In the jungle level, go to Shooter Core Content, Bot folder. Open the Shooter Bot spawner. Select the number of bots to create to 0. Go to Shooter Core Content Blueprint. Drag and drop the Launcher Up blueprint into the viewport. In the details section, under the launcher, change the value for up override to 1500. This is the vertical height the character will jump when moved over the launcher. Run the level. Move the character over the launcher up and you can see the character jumped up high. Stop the game. Now drag and drop the launcher push blueprint into the viewport. In the details panel, under the launcher section, check the use target checkbox. Change the target X value to 1500 and Z value to 400. The character will be quickly pushed in the X direction. Run the level and move the character over the launcher push and you can see the character quickly pushed forward. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the portals in Lyra. The portals are used to teleport the character from one location in the level to another location in the same level. Go to Shooter Core Content Blueprint. Drag and drop Teleport Blueprint into the viewport. Place another teleport in a remote location. For the second teleport, under Details, add an item to the teleporting target. Choose the first teleporter. Go back to the first teleporter. Under Details section, add an item to the teleporting target and add the second teleporter. Now run the level. You can enter into the first teleporter and you will be out of the second teleporter. Same way, you enter the second teleporter and you will get out of the first teleporter. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore how the front-end screen with the menu works in Lyra. Go to Content, System, Front-end Maps. Open the Lyra front-end level. When you look at the front-end screen, you can see the main menu and a moving background. This front-end screen is also a level Lyra front-end, which is configured as Lyra front-end experience. Go to the window world settings. You can see that the default gameplay experience is set to Lyra front-end experience. Go to edit project settings. Under maps and modes, choose Lyra front-end level in both editor startup map and game default map. This will enable you to load the front-end level each time you open the Unreal Editor. You can change this anytime. When the game is deployed, this will be the first experience to get loaded to display the main menu screen. The level has a blueprint load random lobby background. It loads a random game level as a background to the main menu. This is done using the Lyra lobby background data asset. The shooter game lobby BG is the data asset of type Lyra lobby background, which loads the background level in the Lyra frontend screen. Shooter game lobby BG is configured in the shooter maps game feature data. Go to shooter maps content, open the shooter maps game feature data. You can see Lyra lobby background configured here. Under directories, items backgrounds is configured. Under items background, shooter game lobby BG of type Lyra lobby background is available. Open it. You can see the level shooter front-end background is configured here. The asset manager dynamically loads all the data assets of type Lyra lobby background in the configured folder. Shooter game lobby BG has the shooter front-end background level configured in it. Let's open the level. The level has a level sequencer lobby screen. It has two moving cameras from both the ends of the building for the two teams. This brings the cinematic moving sequence in the front-end screen. You can right-click edit the sequencer lobby screen and you can see there are two cine camera actors available. Now let us use this approach to show our jungle scene as background to the front-end screen. In the shooter maps content maps folder, duplicate the jungle map and rename it to jungle map background. Open it. Go to Windows World Settings. Choose None for game mode override and default gameplay experience. Save it. From the level sequence folder, drag and drop sequence lobby screen into the viewport. Edit sequence lobby screen. For the sake of simplicity, delete the cine camera actor B and also the section referencing the same. Adjust the close end of the sequencer. Under camera component, transform location Z, first click to the front button and bring the pointer to start. Change the value of Z from -250 to +250. Verify the same value 250 is there throughout the timeline. Save all. Now select the sequence lobby screen and under details section, select autoplay to true and loop indefinitely. Save all. Go to shooter maps content, items, background. Open shooter game lobby BG. Choose this jungle map background. Now go back to the front end level. Run the level to see our jungle level in the background. In upcoming lectures, we can see how we can customize this menu screen and add our own colors and content and so on. Thank you for watching this lecture. See you in the next one.